Next are the resistors, so I sorted them by color and by value. It's nice that there aren't that many different types. Here we have the 1K resistors. There's 10 of them. Then we have 3 6.8K, 3 470 ohms, and then 3 odd ones, 3.3K, 1.8K, and 180 ohms. So for the resistors, we need to look again for the actual value on the board. So we're going to start with the 1K, and they're even kind of hard to read. And this is not the more common way of putting resistors. Normally resistors are set up like diodes, so they go flat on the ground on the board like this. These are intended to go in one way like this and then bend over. So bend them before like this. There you go. So it's supposed to end like that. And we need to do that with all the 1K resistors first. The last 1K resistor is not very clear where it goes. Maybe there. So that's the problem with the board being so tiny. It's very cramped, and then not having the labels. It would be easier to say R7 than it would 1K. So I'm gonna have to go check on the picture on the website to make sure that's the correct location. So this is a perfect example of why the labeling is not ideal. I actually made a mistake. This in here doesn't say 1K, it says 1K8. I don't know if you can appreciate it or not. And it turns out that that one, which is under the capacitor, so another bad labeling, that one and that one are 1K. So that's where the two 1Ks go. And then the other ones are all accounted for. So let's undo that one. That was a little trickier because I had already cut the leads, but it's all good. Okay, that's all the 1K resistors. So now let's grab the next group, which is the 6.8K. And it explains in the bill of materials that it's blue, gray, red, and gold. It never hurts to double check those things. So let's check it. So exactly, well, not exactly, but close enough. 6.8, good. Next up is the 470 ohms, and this time let's just use the color coding, although it's always good to check with a multimeter. But here we have yellow, violet, brown. Yellow is 4, violet is 7, so it's 4.7, times brown is the multiplier, and is 100. So 4.7 times 100 is 470. Perfect. And it looks like the 3 470s go right here. And now we're just left with 3 different resistors. All done with the resistors. Next is the serial port, which has a lot of pins, but I think it's very straightforward. It goes right there. And as you can see, we're saving the biggest part for last. Then we have the PS2 connector. Okay, you have to press that one a little bit. Right, to make that snap in, that part. And finally, the SCART connector. Okay, you really had to press hard for those. And there you go, that's everything. Cool, so there's one more thing we have to do. Need to clean the flux residue. So as usual, I'll use an anti-static brush and some isopropyl alcohol. And just scrub generously all over the bag since we haven't done it before. Now, if all you do is this, you mostly smear the flux residue and maybe you get some of it on the brush. But if then you put some kind of a rag and do this, it soaks up the alcohol with all the junk in it. And yeah, you can see it's not perfect over here yet. So let's do it again. There we go. Much better. So it's finally time to give it a try. But before, let's learn what it's capable of doing. The CB2 aims to be a tiny microcomputer. But what is it exactly? It doesn't have the traditional architecture you expect from a microcomputer from the 80s. If it did, it would be much bigger and expensive kit to build. Instead, it's based around a single microcontroller. A microcontroller is a single chip containing most of what we normally think as a microcomputer. An 8-bit CPU, RAM, ROM, an I/O controller, and then it has some things that an 8-bit microcomputer didn't normally have, like flash memory or an EEPROM. In particular, this microcontroller is the ATmega644P, which has the following: a 20 MHz RISC CPU, 4 KB of static RAM, 64 KB of flash memory, and 2 KB of EEPROM. All those memories sound pretty reasonable, but the CPU definitely stands out at 20 MHz. In comparison, the 6510 on the Commodore 64 ran at a whole whopping 1 MHz. And Z80 computers were typically clocked at 4 MHz, so that CPU seems very powerful. The whole package is preloaded with Tiny Basic, which definitely makes it more like an 80s microcomputer. This BASIC exposes most of the capabilities of the microprocessor and lets you take control of graphic modes, input, sound, etc. On the graphics side, its default text mode is 30 by 23 characters and 16 foreground and background colors. There are some other graphic video modes that go up to 168 by 116 pixels, and colors can be adjusted for each 8 by 8 block, which sounds quite a bit like a ZX Spectrum, doesn't it? Audio is limited to a single channel with a couple of tones, noise, and envelope and volume controls, so not particularly fancy there. Overall, graphics and audio are more like an early 80s computer rather than some of the later, more powerful computers. One last thing.